How you doing, everyone? Sean O'Kane here with ChipEstimate.com and Chip Estimate TV. We're here at DAC 2018, DAC 55, believe it or not, in San Francisco, California. With me today for a second time is Ron Lowman, Strategic Marketing Manager for IoT at Synopsys. Once again, Synopsys also has their IP catalog listed on ChipEstimate.com. In an earlier interview, we talked about AI technology and how it might be applied to various industries, including healthcare, finance, commerce, education, security, and the Internet of Things. Our topic today, ladies and gentlemen, is embedded vision processing and high performance CNNs, that's convolutional neural networks for deep learning applications. What is embedded vision? And what are the typical applications for that?
So typical applications for embedded vision would be something like object detection, facial recognition. Those are things that are now being handled by camera systems throughout the industry. Okay,
yeah. And okay, so security and also automotive,
right.
Big time.
Yep.
And how is deep learning changing, deep learning technology changing the vision space? Okay.
Deep learning, specifically convolutional neural networks, that's really revolutionized the vision market, is really being able to identify patterns much more accurately than previously. In the past, algorithms such as support vector machines have been used, but CNNs really revolutionized the embedded vision market. So the ability to use these deep learning AI algorithms has upped the accuracy even beyond what a human can recognize. So it's a really huge step forward in the technology standpoint.
Right, and autonomous driving has been, well, in the news in the recent days, and let's say months, for various reasons. But let's talk about AI and what are the special EV requirements for AI applications?
Yeah, so it's really around the processing, but also the memory bandwidth. With respect to the processing, it's not just the CNN engine. Of course, CNN engines require massively parallel matrix multiplication. But in addition, there's still a scalar and vector DSP component around artificial intelligence that has to be handled. And so Synopsys provides solutions that include all of those components in single solutions, or a piece of those throughout our portfolio.
How does Synopsys differentiate themselves in the vision space, the vision market?
So we have a complete, fully integrated EV vision processor, and that includes the scalar, vector DSP, and the CNN engine. We also have the mapping tools required, so these algorithms are trained in the data center, and then they're optimized on our processor so they can fit into a much more efficient memory architecture. But we really differentiate ourselves via the fact that we have performance per square millimeter. Because these are cost, specifically in automotive, cost constrained devices. And the other piece is that because it's in the automotive space, you need automotive qualification, and we've done that with our processors and our interface IP.
Okay. That leads to our next question: is best practices. What is best practices for evaluating vision technologies?
Well, there's several components. I talked about the automotive component, which requires high reliability, also a lot of documentation about the reliability of not just the device itself, but the process of the design. So there's a lot of standards around that, like ISO 26262. And but then the other component is the algorithm itself. So best practices around optimizing the algorithm is understanding which algorithms you want to run on that processor, how you best want to optimize it for that processor, and then the memory architecture that goes around that processor. So having lots of options to be able to build a very efficient system is critical.
Yeah, all right. What else is new and exciting for Synopsys? Are your booth is downstairs here at DAC, right?
Yes, it is, yes. And we have lots of information on our complete portfolio with respect to artificial intelligence as well as other markets.
Fantastic. Thanks again for being here with us. For Ron Lowman, my name is Sean O'Kane. We'll see you next time on Chip Estimate TV. Thanks, Ron.
Yeah, thanks.
All right.